Example 5-3. A steering basin at the toe of the spinway shown in below figure which has a width of the 180 feet and carry a desired discharge of the 24,500 cubic meter per second, cubic foot per second when upstream leg elevation is 32 feet. Okay, and at this discharge, the tailwater elevation in the channel downstream of the spinway is 25.6 feet. Determine the elevation of the floor and choose the type and dimension of the steering basin. Neglect the spinway head loss. Okay, given data we have the width of the spinway. This is 180 feet. Total Q is the 24,500. So we want to find the height and dimension of steering basin. Okay. So we start from 5. What is the flow per unit width? From this is Q divided by B. Q is 2000 divided by 180. We got the 136 cubic foot per foot. Okay. Or if we convert to cubic meter, is about 12.6. Cubic meter, cubic. Okay. And YC is equal to Q power 2 divided by is 8.31 feet or 2.53 meter. And next we have to assume steering basin floor elevation. Z is equal to, let's say, 10 feet. So if we assume this, okay, assume that the bottom of the steering basin floor elevation 10 feet. And next we check the energy. Energy equation between upstream reservoir to the toe of the spinway. Okay, so energy in the upstream is equal to 32 feet equal to okay, so we just substitute number in for y1. It is unknown. Q is the 136. Then the Q is 32.2, and y1 square, and plus the z is 10 meter. Okay, the next step we have to solve this equation to find y1 by trial and error. So we get y1 is equal to 3.99 feet or 1.2 meter. Okay, then next we check the V1. We do C at point 1 is equal to Q equal to YY1 equal to 34.1 feet per second or 10.4 meter per second. We check the foot number as 0.1 if equal to again that is that 32.2 3.99. Okay, so we got 3.01. Let's say that is a supercritical flow. Supercritical flow. Okay, so we choose the steering basin type 4. Okay, for detail of the design of the steering basin, tail water depth is equal to it's just the specification for design the steering basin. The tail water depth divided by y2 is equal to 1.1. And the next we solving for the sequence depth of the jump. y2 is equal to y1 divided by 2. Okay, we substitute y1 3.99 divided by 2, subtract 1 plus foot number at point 1. So we can estimate the y2 is equal to 15.1 feet. In this case, the tail water depth is equal to 15.1 times 1.1. So we got the 16.6 feet. Okay, we move to on the top again. Water level elevation. So we check the water level elevation. Is equal to z plus the 1.1 y2. So is equal to then plus the 16.6 is equal to 26.6 feet, but is greater than 25.6 feet. So we expect that if this is above the 25 means jump will sweep. sweep out the basin, and this is called erosion on downstream channel. So you have to repeat calculation again with the lower basin level. Let's try and set is equal to 8.5 meters. Okay, so we have to change the depth here to 8.5 feet. Okay, and repeat the calculation again. We can get y1 is equal to get v1 and foot number is y1 is equal to, and check the sequence depth. Y2 is equal to 15.5, and check the water again. The water elevation go to says part 1.1 of the depth. So we got about 25.6. So it's about the level of the is okay, yes, because it's equal to elevation of the downstream channel. Okay. So this one, so required, we conclude that required floor elevation equal to 8.5 feet, and for the length of stirring basin that is just the specification for design. It's about 5.5 times. In this case, L2 is equal to 5.4 times the depth D2 and D2 or Y2 is the same. The depth is with Y2 is 15.5554. Okay, so the length of the steering basin is about 84 feet. Okay, and the steering basin height, still height, 1.25 of the y1, so is equal to 4.58 or 1.5 meter. And the last one is chute block W is equal to, from the spec is 3.5 is less than y1. Okay, it's okay, we can choose the width is up, and with spacing of 2.5 of the width, so we have to use 8.8 feet for the spacing of the chute. Okay, that's just a detail of to design the steering basin dimension.